Welcome YouTubers to another episode in my Grammar Hero series. In today's video, I'm going to show you the solutions to the fifth mathematics knowledge practice test on my website. In case this is your first time finding my YouTube channel, I want to quickly mention that I recently created a website called mastertheasvab.com. There you can take 6 practice tests as well as estimate your AFQT score. All that said, let's go ahead and get started with today's video. Question 1 says, if 2 plus x is greater than or equal to 4, what is the value of x? Select all that apply. So we have 2 plus x is greater than or equal to 4. What is the value of x? In other words, we want to solve for x. To do that, I'm going to subtract 2 from both sides to get x by itself. This crosses out. I'm left with x is greater than or equal to 4 minus 2 is just 2. And the way we represent this is on a number line. Let's have this one be 0, 1, 2, 3, 4, 5, 6. The fact that this says this is greater than or equal to 2 means that we're actually going to include the 2, which means we place a closed circle above 2, and that includes all the values that are greater than 2. As we can see, we include 2, 4 is greater than 2, and 6 is greater than 2. A lot of people make the mistake of flipping the sign when they subtract. You only flip this inequality when you either multiply or divide by a negative. You can subtract from both sides and this inequality does not change. If I were to do, let's say I had this problem. Let's say it was negative 2x greater than or equal to 4. Again, I would have to solve for x, so I'm going to divide both sides by negative 2. In this case, I divided both sides by negative 2, so I would flip this inequality to this way, and this would be negative 2. Again, subtraction across the inequality does not prompt you to flip the direction of the inequality, whereas multiplication or division by a negative prompts you to flip the direction of that inequality. Okay, so just keep that in mind. Let's go ahead and move on to number 2. And again, I like to think that the mathematics knowledge subtests are easier than the arithmetic reasoning subtest. They generally require less arithmetic, which means they're less tedious to work out. Number 2 says the sum of the measures of the angles of a trapezoid is. So to do this one, we have to recognize that a trapezoid, which looks like this, is a quadrilateral. We should know that triangles add up to 180 degrees. Quadrilaterals, which are squares, rectangles, and trapezoids, and rhombuses, add up to 360 degrees. That said, if you didn't know the fact that that was the case, you can also use this formula to find the sum of the interior angles of any shape, and that is the sum equals 180 times n minus 2, where n refers to the number of sides in the figure or shape. In this case, there's 1, 2, 3, 4. So we would do 180, 4 minus 2. 180, 4 minus 2 is just 2. 180 times 2 we should be able to do in our head, which is 360. Again, this formula you should commit to memory, because what if I said, what are the sum of the angles of a decagon, which is a 10-sided figure? You'd be able to plug it in. S equals 180 10 minus 2, s equals 180 times 8, and you can solve that one accordingly. So again, try to devote this formula to memory. It's useful, and it's not that hard to remember. So that said, let's go ahead and move on to the next question. Number 3 says the circle measures 12 feet in diameter. What is its area to the nearest foot? On the ASVAB, you're going to see questions in regard to circles. So you need to know how to find the area as well as the circumference of circles. In this case, we're being asked to find the area. And let me just do a little sketch when we're given the diameter. Again, the diameter is this total distance across from one side to the other side through the center of the circle. We're told that's 12. We want to find its area. The formula to find the area of a circle is pi r squared. Now, if we know the diameter is 12, that means the radius, which is half of the diameter always, is going to be 6. So in light of that, I can go ahead and start plugging things into this formula. Again, even though it's not stated here, since we're working things out by hand, we're always going to use 3.14 for pi. So let's go ahead and plug that in. 3.14 for pi. Again, this radius is 6, and that's squared. 3.14. 6 squared is 36. So now we have 3.14 times 36, which looks like this. That is, we're doing the multiplication of a decimal and a whole number. In order to do this, we actually have to make this decimal a whole number by shifting this decimal 2 times to the right to make 3.14 314. At the very end of this problem, I'm going to add 2 decimals back into the left. So I have 314 times 36, albeit with 2 decimals to add back in. Let's go ahead and work on it. 6 times 4 is 24. Carry the 2. 1 times 6 is 6, plus 2 is 8. 3 times 6 is 18. Since we're starting this number, we have to add a 0 before we begin. 3 times 4 is 12. Carry the 1. 3 times 1 is 3, plus 1 is 4. 3 times 3 is 9. Let's go ahead and add. 4 plus 0 is 4. 8 plus 2 is 10. Carry the 1. 8 plus 4, 8, 9, 10, 11, 12. Plus 1 is 13. And add the 1. 9 plus 1 is 10, plus 1 is 11. We're going to go ahead and shift our 2 decimals back in. So this is 113.04. In the problem, we're asked to round to the nearest foot, which is right here. So we look at this 0, and this 0 prompts us just to round down to 113 feet. So the area, when rounded, is 113 feet. Okay, so that's that one. Let's go ahead and move on to the next one. All right, this one says, 4 says, if a rectangle has a perimeter of 36 feet and it is 4 feet wide, what is its area? So again, we know we're dealing with a rectangle, which has a length, a width, and a width. We're told the width is 4 feet, and its perimeter is 36 feet. In order to find the area, I have to figure out how long this rectangle is. Again, if this width is 4, this is 4. Since I don't know the length, I'm going to represent that as x. So if that length is x, this length is x. It's not 1x, that's just x next to an L. So the perimeter of to find the perimeter of any shape, you simply add up all the sides. In this case, we know our width is 4, and there's 2 of them, so this is 4 plus 4. I represented my length as x's, so that's plus x plus x. And in addition, I know the perimeter is 36, so I can go ahead and plug that in. 4 plus 4 plus x plus x. Let's go ahead and combine like terms. 36 equals 4 plus 4 is 8. X plus x is 2x. Now we're going to solve for x by subtracting first 8 from both sides. This crosses out. We're left with 36 minus 8, which is 28, equals 2x. Divide both sides by 2. This crosses out. We're left with x equals 28 over 2. X equals 2 goes into 2 one time. 2 goes into 8. 2 goes into 8 4 times. So I know x, or the length of this rectangle, is 14. So that's going to be 14. That's going to be 14. Again, the area of a rectangle is length times width. So let's go ahead and solve this. Area equals, we know the length is 14. We know the width is 4. So the area is going to be 14 times 4, which is 14 times 4. 4 times 4 is 16. Carry the 1. 4 times 1 is 4, plus 1 is 5. The area, in other words, of this rectangle is 56 square feet. So again, in this case, we were given the perimeter as well as the width of the rectangle. To find the area, we had to figure out what the length of the rectangle is, and then we can use the area formula to solve accordingly. So a lot of small stuff to work through, nothing too difficult. So let's go ahead and move on to the next one. Okay, so this is a one-step equation. It says if 0.05 times y equals 8, then y equals. So 0.05 y equals 8. We're going to solve for y by dividing both sides by 0.05. So this crosses out. We're left with y equals 8 over 0.05. That's not an answer choice, unfortunately. So we have to regard this fraction as long division, namely 8 divided by 0.05. The key to doing division in fractions is this. If the decimal is inside the division bracket, you can go ahead and do the division. If, however, the decimal is outside the division bracket, which it is in this case, you have to shift this decimal accordingly to make this number a whole number. And whatever you shift, however many times you shift it outside the division bracket, you have to shift it inside the division bracket the same number of times. So this is really 8.0. So I'm going to shift this 2 times to make that just 5. So I'm going to have to shift this 2 times to make this 800. So in reality, I'm doing 800 divided by 5. And I know 5 goes into 8 one time without going over. 5 times 1 is 5. Subtract. 8 minus 5 is 3. Drop down this 0, drop down this 0. 5 goes into 30 6 times, therefore 5 goes into 300 60 times 5 times 60 is 300. So we can see there's no remainder. In other words, 8 divided by 0.05 is 160. Again, this problem's testing your ability to solve a one-step equation, but beyond that, it's also testing your ability to do division with decimals outside the division bracket. Okay? So that was that one. All right, number 6 is testing your knowledge of some mathematical definitions. It says the complement of an 80-degree angle is. So as far as angles go, you have to know the difference between a complementary angle and a supplementary angle. A complementary angle is when two angles, angle 1 and angle 2, let's say, add up to 90 degrees, whereas supplementary angles, let's call them angle 3 and angle 4, add up to 180 degrees. That is a straight line. In this case, we're dealing with a complement of 80. So I know 80 plus angle 2, let's say, equals 90. Therefore, we can clearly see that 80 plus 10 degrees for angle 2 will get us 90 degrees. Okay? So, again, supplementary and complementary angles, you have to know the difference between those to do well on this test. And they're very easy. Complementary, add up to 90. Supplementary, add up to 180. All right, number 7 says, in which quadrant would the coordinates negative 540 be located? So again, we're working on a coordinate plane, which you may have seen in algebra. It looks like this. And the way the quadrants are numbered is like this. This is quadrant 1. This is quadrant 2. This is quadrant 3. Quadrant 4. Again, the ordered pair in quadrant 1 are positive. Positive, again, this is positive and this is positive. Your y is positive and your x is positive. In quadrant 2, the ordered pair is negative. Positive, again, your x goes negative, whereas your y is still positive. In quadrant 3, your x and your y are both negative. Negative. And in quadrant 4, your x is positive, whereas your y is negative. Okay, and again, this is your x, and this is your y in the ordered pair. Our x in this case is negative, so we're going to go here. And again, x goes left and right, whereas y goes up and down. Negative 500 somewhere over here. Positive 40 somewhere up here. So we can see that this point's somewhere in quadrant 2, which is right there. Okay? All right, number 8 says the square root of 1654 is a number between. So again, this is square root of 1654, which is not necessarily easy to do, given that this is a large number. That said, we can use some mental math tricks to help us estimate this, since that's all they want us to do. Square root of 2 is 4. Square root of 20 is going to be 400. Square root of 3 is 9. Square root of 30 is 900. Square root of 1 is just 1. Square root of 10 is 100. Square root of 20, as I just said, or the square of 20 is 400. The square of 30 is 900. The square of 40 is 1600. Again, 4 squared is 16. Therefore, the square of 40 is 1600. Again, the square of 40 is 1600. Square of 50 is 2500. Okay? 1650, as we can see, falls between these two numbers, so we know that the square root of 1654 is going to be somewhere between 40 and 50. Again, not a difficult problem as long as you're able to think your way through that one. Okay, number 9 says, what is the perimeter of the right triangle below? To find the perimeter of any shape, we simply add up all the sides. In a triangle, there are 3 sides, so the perimeter of this triangle is going to be side 1 plus side 2 plus side 3. As you can see, we're given 2 of these sides, so I can plug 15 in for side 1, 17 in for side 2, and side 3 I don't know, but that said, this appears to be a right triangle. The side always directly across from the right triangle is called the hypotenuse, and that can always be represented as C. So I'm going to call this third side C. And to find the third side, I'm going to make use of the Pythagorean theorem, which is a squared plus b squared equals c squared, where a and b refers to the legs of the triangle, and c refers to the hypotenuse of the right triangle. So I'm going to let a equals 15, b be 17, and c, which is our unknown we're trying to solve for, just plug that in accordingly. I know 15 squared is 225, so I don't have to work that one out. That said, I don't know what 17 squared is, so I'm going to work that off to the side. 7 times 7 is 49, carry the 4. 7 times 1 is 7, 8, 9, 10, 11. Add a 0 since we're starting that 1. 7 times 1 is 7. 1 times 1 is 1. Let's add. 0 plus 9 is 9. 7 plus 1 is 8. 1 plus 1 is 2. So this is 289 equals c squared. Let's go ahead and add 225 and 289. Five plus 9 is 14, carry the 1. 8 plus 2 is 10, plus 1 is 11, carry the 1. 2 plus 2 is 4, plus 1 is 5. So we can see this is going to be 514 equals c squared. Let's take the square root of both sides. This is c equals the square root of 514. Now this is where we may run into some trouble. I know that the square root of 514 is not going to be a whole number. But that said, we got to find a way to estimate it, to plug into c here, that allows us to quickly and accurately solve this problem. I know 20 squared is 400. Therefore, I know the square root of 514 is going to be somewhere between 20 and 25-ish. So I'm just going to start taking some stabs at it. I'm going to say 22 times 22 and 23 times 23. Let's see if these get me close to 514. 2 times 2 is 4. 2 times 2 is 4. Add a 0 since we're starting that 2. 2 times 2 is 4. 2 times 2 is 4. 0 plus 4 is 4. 4 plus 4 is 8. 4 plus nothing is 4. Okay, that gets me close, but it's not quite there. 3 times 3 is 9. 2 times 3 is 6. Add a 0 since I'm starting this number. 2 times 3 is 6. 2 times 2 is 4. 9 plus 0 is 9. 6 plus 6 is 12. 4 plus 1 is 5. So, in light of that, I know that the square root of 514 is going to be 22 point something. So this is going to be 22 point. And when I say 22 point something, there's actually a shortcut as to how we can get pretty close to it. And here's what it is. We take the difference of the square and this number, so it's going to be 514 minus 484. 4 minus 4 is 0. 8 minus 1 I can't do, so this becomes 4. This becomes 11. 8, 9, 10, 11. This is 3. That's 0. So the difference is 30. So this is going to be, and let me get rid of this decimal for the time being so I can show you this little shortcut. You take the difference of the square, which is 514 minus 484, which is 30. You put that over double this whole number. So 22 doubled would be 44. And this is how you approximate this decimal. 22 point, and again, this is a little less than 0.75, so I'm going to call it 0.7. If you were to actually use your calculator to figure out the square root of 514, it'd be 22.67, which we can round up to 22.7, but I use this little shortcut right here to approximate that very accurately and quickly. So now I can take this and plug it in over here and solve accordingly. Again, this is 15 plus 17 plus 22.7. Let's go ahead and add vertically. We got, and let me free up some space here. We got 22.7, 17, and I'll put 0.0 just to line that up, and 15.0. Again, this is going to be 0.7. 7 plus 5, 7, 8, 9, 10, 11, 12, 13, 14. So this is going to be 4, carry the 1. 2 plus 2 is 4 plus 1 is 5. So we can see that this perimeter is going to be 54.7. And that's just an approximation using this little handy trick. And as we can see, that is the correct answer choice. Okay? So again, let me touch on this again. I determined that 22 got me the closest to the square root of 514 without going over. So I took 514 minus this square, which is 484. That got me 30. I took 30, placed it in a fraction over double of 22, which is this number. And that's how I got this approximation of 0.7. Okay? So that's the shortcut as to how to do these approximations for square roots that aren't even. Okay, so let's go ahead and move on to the next one. Again, that one was pretty tedious, and you'll run into problems on test day that can be tedious. All right, number 10 says x to the 4th times x to the 5th times x to the negative 3rd. In the formula sheet on my website, you'll see the very first section talks about exponents, and it tells you whenever you multiply exponents, let's call this M, N, O. Whenever you multiply exponents that have the same base, you simply just add them. So this would be A, M plus N plus O. And as you can see, that's the case we have here. So this would be x4 plus 5 minus 3. 4 plus 5 is 9. 9 minus 3 is 6. So this would just be x to the 6th. Now, if you want to double check your work, which I don't recommend because you're dealing with exponents, you can actually substitute a value in for x and see if this gets you the value when you sub it in. So you can do 2 to the 4th times 2 to the 5th times 2 to the negative 3rd, and you can work that out and see if that gets you 2 to the 6th. If these are equal, you know it checks out. Again, that's one way to do it, but if these numbers get too big, which they're starting to, just trust the fact that you know your rules of exponents or your laws of exponents and move on. Again, all the laws of exponents are in the formula sheet if you want to refresh your memory as to how to do those. I may make a video on the laws of exponents eventually. Alright, number 11 says if x equals 6, so I'm just going to start copying it off to the side here on my scratch paper. Y equals -2 and z equals 3. What is the value of the following expression? So we have xz minus xy all over z squared. Let's go ahead and plug things in accordingly. We have 6 times 3 minus 6 times -2 all over 3 squared. 6 times 3 is 18 minus 6 times -2 is -12 all over 3 squared, which is 9. In this case, we have minus minus, which we can't do. This has to become positive. Minus minus becomes positive. 18 plus 12 is going to be 30 all over 9. And we can reduce this by a factor of 3. I'm going to divide top and bottom by a common factor of 3. 30 divided by 3 is 10. 9 divided by 3 is 3. So we can see that this is 10 over 3, which unfortunately is not one of our answer choices. So we have to work this out even further. And again, all fractions can be regarded as long division. 10 over 3 is the same as 10 divided by 3. So we can go ahead and work this out. 10 goes into, or 3 goes into 10 3 times without going over. 3 times 3, of course, is 9. Subtract. 10 minus 9 is 1. 3 doesn't go into 1, so we have to add a 0. When we add that 0, we have to add a decimal place right there. 3 goes into 10 3 times. 3 times 3, of course, is 9. Subtract. Drop down a 1. Again, we have to add a 0. As we can see, this is going to repeat, so this is going to be 3.33. Repeat it. Okay, so that's that one. Again, the hardest part of the ASVAB is, especially for the math sections, is it combines 4th grade arithmetic with 9th grade basic algebra. So again, a lot of people are pretty good with the algebra or the basic algebra, but what really trips them up is the 4th grade arithmetic. So again, take your time as you work through my videos. I show you all the steps in the arithmetic. So if you're struggling with arithmetic, just keep watching my videos. The more you watch, the more you're going to see different methods for solving different problems, and eventually it should start clicking. Number 12, what is the area of the figure below? So we got this L shape here. We want to find the area. Unfortunately, we only know how to find the area of rectangles, squares, triangles, and so on. So in this case, we're going to have to make a split to make this shapes with which we're familiar. I'm going to split this into 2 rectangles. This is going to be a 2 by 5 rectangle. And again, this 7 goes all the way up to there. So when I cut this off, which is 2 right there, this rectangle length right here is just going to be 7 minus 2, or just 5 feet. So I have a 2 by 5 and a 2 by 5 rectangle. Again, area is length times width. So this is going to be area 1 plus area 2. Area 1, as I said, is length times width, so 2 times 5. This one's also 2 by 5. This is 10 plus 10, which is just 20. Again, whenever you're given weird shapes and you're asked to find the area, you have to split them up into shapes with which you're familiar. In this case, 2 identical rectangles. You have to make adjustments to the measurements when you cut things off, and then you apply the basic formulas of the shapes you know and add them accordingly. Pretty easy. All right, number 13 says, on a number line below, point L is to be located halfway between M and N. What number will correspond to point L? So let me go ahead and blow this number line up for you. We have -3 right here, and we have, let's go ahead and just fill this in. -2, -1, 0, 1, 2, and 3. This one, M, is right on -3, whereas N is halfway between 2 and 3. So I know this is -3, and I know this is 2.5. We're being asked to find L, which is the midpoint, or halfway between these two. To find the midpoint, you do x1 plus x2 divided by 2. Again, that formula is in the formula sheet. In this case, we're going to let -3 be our x1 and 2.5 be our x2. So let's plug it in accordingly. -3 plus 2.5 divided by 2. Let's keep working this out. -3 plus 2.5 is -0.5 divided by 2. -0.5 divided by 2, well, half. It's going to be -0.25. And -0.25 is the same as -1/4, which is right there. Okay? And that would be somewhere like right here for L. Okay, so that's that one. And as you take these practice tests, you should find that the mathematics knowledge practice test is slightly easier than the arithmetic reasoning practice test. Again, more often than not, the mathematics knowledge practice test is very easy for you to compute the math, whereas the arithmetic reasoning really requires you to be very proficient with decimals, fractions, and so on. So number 14 says solve the following system of equations. And again, this is something you probably learned in Algebra 1. The key to solving a system of equations is to multiply one of these equations by something, add it to the second equation to knock out one of the variables, and then solve for one of the variables. In this case, I think it's going to be easier if I multiply this top equation by -5, because I know -5 plus +5 would be 0, which would just leave me with the y's, which I can then solve for the y variable. So let's go ahead and do that. Again, -5 times x is negative 5x. Negative 5 times negative 7 is going to be positive 35y. And negative 5 times negative 11 is going to be positive 55. Okay, and as I said, I'm not going to touch the second equation. That's going to be 5x plus 2y equals negative 18. And as I said, we're going to add these two equations together. Negative 5 plus 5x, that just goes away. 35y plus 2y is going to be 37y. And 55 minus 18 is going to be 37. Solve for y at this point. We're going to divide both sides by 37. This crosses out. We're left with y equals 1. Now at this point, I can look at my answer choices. Again, this is your x. This is your y ordered pair. And look for the one that's just 1. That's 11, so that can't be it. That's 0, so that can't be it. It's 2, so that's not it. That's 1. So I'm pretty sure that this is going to be the solution. That said, once you solve for one of the variables, you plug it back into the original equation and solve accordingly. So I'm going to take this y and plug it into this first equation. And that's going to look like this. X minus 7 times 1 equals negative 11. X minus 7 equals negative 11. X equals, and we're going to add 7 to both sides to get rid of it. This crosses out. X equals negative 11 plus 7, which is just negative 4. So I know if I were to place the solution as an ordered pair, it'd be negative 4, 1. Okay? So that's how you solve those. I can show you another method using matrices, but that's probably going to be too advanced for the ASVAB. So just use your rules of solving system of equations to deal with those accordingly. Let's go ahead and move on to 15. I grabbed my pen too soon there. Okay, let's go ahead and grab the pen. 15 says simplify ax squared minus bx minus a squared y plus by plus a squared z minus bz. So let me go ahead and copy that. A squared x minus bx minus a squared y plus by plus a squared z minus bz. Let me rewrite that. That's too big to fit on my screen. Sorry about that. Let me rewrite that for you. Got a squared x minus bx minus a squared y plus by plus a squared z minus bz. So we have to figure out how to solve this one, and as it turns out, we're going to solve this one using factoring by grouping. So right away I notice a squared, a squared, a squared, bx, by, bz. So to make that easier, I'm going to rewrite this as a squared x minus a squared y plus a squared z minus bx plus by minus bz. I can see that from these a squareds, I can pull out an a squared, and that would leave me with x minus y plus z. And from these bx, by, bz, I can actually pull out a, let's pull out a negative b. That would leave me with x minus y plus z. And when you factor by grouping, you combine these two. So we have a squared minus b, and you just take one of these, x minus y plus z. And then you're done. This is the solution, which is right here. If you were to multiply this out by distributing these accordingly, this would actually get you this original equation. So again, I just solved this one by factoring by grouping. It's a fairly advanced problem. If you're doing well on the ASVAB, you might see a problem that requires you to factor by grouping. I just picked this problem randomly, so that's why it ended up on this practice test. But again, factoring will be a part of the ASVAB. Eventually, I'm going to release a formula sheet that basically says what topics you need to know how to deal with. But for now, most of my practice tests include all the topics you'll need to know how to deal with. 16 says convert this to standard notation. We got 6.39 times 10 to the negative 4. The way this works is you take your number 6.39 and you shift this decimal the number of times that this exponent is, and if this exponent were positive, I'd be shifting it to the right. Since this exponent's negative, I'm going to shift it to the left 4 times. 1, 2, 3, 4. Fill in zeros accordingly. So we can see that this is 0.00639, which is right there. Okay? And you will see scientific notation on the ASVAB. That's guaranteed. So that's all I had for you for this video. You may have noticed that some of these questions may have been very similar. You may have seen them. I actually, to create this 5th practice test, I went through the first 4 practice tests and pulled the questions I thought were good questions and combined them into this 5th practice test. So all that said, I hope you found this video helpful. If you did, feel free to give it a thumbs up. If you think my channel's helpful, I encourage you to subscribe to it. I try to post new content as frequently as I can. Usually I try to do 1 video a week. Sometimes I get a little busy and I only get a couple of videos a month. As it stands, I have 10 practice tests on my website. 7 of them, 7 practice tests 7 through 10 are actually hidden right now. Once I upload the solutions to practice test 5 and 6, and I just finished practice test 5, I'll go ahead and make the 7 through 10 practice test available to you. So on that note, I'm going to go ahead and cut you loose. Konnichiwa.